Assalamualaikum dear students, I hope that everyone is well. Welcome to the third session of the week. We have to continue with unit 4 partial fractions, and the topic for today is resolution of fraction into partial fractions when denominator has repeated irreducible quadratic factors. Dear students, before proceeding towards the topic, let's have a brief revision of all the previous topics of chapter 4. So let's begin with the first topic, resolution of an algebraic fraction into partial fractions when denominator consists of non-repeated linear factors. This topic is for exercise 4.1. In exercise 4.1, we came across with such type of fractions in which the denominators were non-repeated linear factors. So the partial fraction of this resultant fraction can be made as a divided by x plus 2 plus b divided by x plus 3. Remember one thing here, that if denominator is linear, so numerator will be 1 degree less than that. So 1 degree less than linear will be constant. It is why because the resultant fraction is in its simplified form, it is a proper fraction. So therefore the partial fractions will also be proper fraction. So the degree of numerator should be 1 degree less than degree of the denominator. Okay, here we have the partial fraction and this is the resultant fraction. Here we have some questions of exercise 4.1. Here you can see that in denominator apparently it seems to be quadratic. Of course this is a quadratic factor, but this quadratic factor can be reduced into linear factors by factorization. So here you can see that we can apply the formula of a square minus b square, so this factor can be converted into linear factors. Fine. Moreover, here again we have the quadratic expression in denominator, but this quadratic expression or denominator can be reduced into linear factors, as by midterm partition we can convert this in linear factor. So you must see that whether the denominator is able to be factorized, it is able to be converted into linear form or not. So you have to be very careful before proceeding towards making the partial fractions. Here we have the next topic of chapter 4, which is resolution of fractions when denominator consists of repeated linear factors. Here we have such type of factors in denominators which are in repetition, like x minus 1 whole square. So the partial fraction of this type of fraction can be made as a divided by x minus 1, whereas the factor which is repeated in the second fraction, it will come with repetition then. Its verification has been already discussed in the previous class, so we'll not go with that ahead again. Then we have the third topic of chapter 4, which is resolution of fraction when denominator consists of non-repeated irreducible quadratic factors. Dear students, in exercise 4.3 we have such type of fractions where the denominator will be linear as well. Moreover, there will be quadratic factors. But what type of quadratic factors? Which cannot be reduced into linear form. In exercise 4.1 we have such type of factors which are non-repeated linear, but there may be the quadratic factors as well, but those quadratic factors can be reduced in linear form. But in exercise 4.3 we will have such type of denominator, means quadratic factors, which cannot be reduced into linear form. So the partial fraction of this type of fraction can be made as, since this is the linear factors, so therefore the constant term will be in the numerator, whereas the denominator here in the second fraction is quadratic, so therefore the numerator will be linear, as the numerator should be 1 degree less than the denominator. So if it is x square, so it will be x raised to the power 1. B is the coefficient of x and c is then the constant term here. Fine. Okay. Here we have means the revision of exercise 4.3. You can see here that we have a resultant fraction, and here we have a quadratic factor which cannot be reduced into linear form, as no formula can be applied here. So therefore it will be written as it is in denominator. Then we discuss some important points that before making the partial fractions, means the fraction should be converted into proper fraction by long division method. Then we have to factorize the denominator if factorization is required. Then we can multiply both sides by the LCM in order to eliminate the fractions. Moreover, we can equate the coefficients of like powers on the both sides in order to find the unknown values. These points were already discussed in the previous classes. So let's start the topic of today, which is resolution of fraction when denominator has repeated irreducible quadratic factors. This is the last topic of this chapter. So let's understand that what this topic states. In this exercise 4.4, we will come across with such type of resultant fraction where the denominator will be quadratic. Moreover, it will be repeated. As you can see here, square, it is quadratic as well, as x is raised to the power 2. Moreover, it is repeated because here we can see a whole square, and it will be irreducible, means it cannot be factorized because x square plus 9, we cannot apply any formula here. If it will be minus, so we can apply the formula of a square minus b square, but here it is plus, so therefore it cannot be reduced into linear form. So it has repeated irreducible quadratic factors. So let's come to know that how the partial fractions of these resultant fraction can be met. Here, since the first factor is linear, so therefore a divided by x minus 3, then plus, we can see that x square plus 9, this is a quadratic factor, so therefore in numerator we must have the linear factor or the linear expression bx plus c. In addition, we can see that since this is repeated, so therefore x square plus 9, in the third fraction there should come square, as this concept has already been discussed in exercise 4.2 where we discussed a repeated linear factor. So the same concept is for repeated quadratic factors. If you will take the LCM of these three fractions, so you will get this big, as x square plus 9 will be one with common factor, and once it will be with non-common factor, so we'll get this denominator big in resultant fraction. Okay, here means the first one is a unknown value, then b, after b we can let c in the means organized way we will go, then after c d, then e. So these, how many values we are going to find? A, b, c, d and e. 5 unknown values exist in these fractions. So let's begin with the exercise, then you will better understand. We have to resolve this into partial fractions. We have a single or resultant fraction here, so let's resolve this into partial fraction. Let's find the components or the parts of this fraction. So here we have the fraction. Now we can see that x square plus 4 is the denominator, as it is quadratic, so in numerator we will be having x plus b. Moreover, it is in repetition, so in the next fraction it will come with the square. Then after b we will have x plus d. Okay, in order to solve this, or in order to find the unknown values, we have to multiply both sides with the LCM in order to eliminate this fraction. So what will be the LCM? Of course the LCM will be x square plus 4 whole square. If you will take the LCM of these two, you will get the same thing, as this is the whole and these are the parts. Okay, when we will multiply this, so let's see that what we will get here. This will get cancelled with this, so here we will just have x cube. Now the x square plus 4 will get cancelled, so ax plus b, you must put bracket here because it's 2 times, so 1 time will be left here. Okay, so next one, this one will get cancelled with this, so cx plus d will come, or will be left here. Next step is that we have to go with further expansion of this bracket for equating the coefficients. So these two brackets should be multiplied. X with x square will get, you will get x cube here, then 4ax you will get get b with x when multiplied, you will get bx squared, then 4 with b, then 4b. Cx plus d is written as it is. Okay, here you can see that, as I told you earlier, that you can derive the value of x from the linear factor, whereas you cannot derive the value of x from the quadratic factors, because if you will do so, you will get an imaginary answer, but you need real numbers in order to put and find the unknown values. So here, since we don't have any linear factor to find the value of x, so we will go with equating the coefficients method. Here we can see that four unknown values are means we are going to find four unknown values a, b, c and d. And how many terms we have? X cube we have, x square we have, and x we have, then constant terms we have. So we have to equate all these in order to find the unknown values. So first of all, if you are going to find the value of a, so a is with x cube, so we can equate the coefficient of x cube here, then x square, then x, then constant term. So let's go with it. To find a, b, c and d, we have to equate the coefficient of x cube, x square, x and constant. So coefficient of x cube first. Let's see the here. X cube we have, with x cube we have 1, and here for x, with x cube we have a, and at this side of the equation we have the coefficient of x cube as 1. So the first equation can be a is equal to 1, this one. Now let's see that what will be the coefficient of x square. The coefficient of x square will be b, and at this side of the equation we don't have any x square, so it will be 0. So b will be equal to 0. So let's go with the next. Now coefficient of x, here you can see c is written with x, then 4ax is also written, means the coefficient of x can be 4a, the coefficient of x can be c. Moreover, we don't have any x here, so it will be 0. So 4a plus c is equal to 0. 4a plus c is equal to 0 will be the coefficient of x. Now we are left with the constant term here, so you can see 4b is a constant because no variable x is written with this, then d is the constant, so 4b plus d will be equal to 0, will be the 4 equation. Okay, using these equations we are going to, here is directly a, the value of a will be 1, the value of b will be 0. Now we are going to find the value of c. So here we have two unknown values, a and c, but when we will put the value of a, is already it is known here, so we can find the value of c. So put a is equal to 1, equation number 2, we will get c equal to -4. Moreover, we have to find the value of d, and we know the value of b, which is 0. So when we will put the value of b as 0 here, so we can find the value of d. 4 0 is 0, so the value of d will be 0. Here all the values are found out, so we are going to put this back in the equation or in the partial fractions. Here this is the value of ax plus b, this is 0 is the value of b, then -4 is the value of c, and 0 is the value of d. Okay, x1 is x and 0, if you don't write that doesn't matter. -4x minus plus minus here, then this is the required partial fractions. If you will solve this partial fraction back by taking the LCM, so you will get this resultant fraction again. Here we have question number 3 now. Okay, so you can see here that here we have quadratic linear factor as well and quadratic factors as well, which is in repetition. So here it will be x plus 1. I think this is a minor mistake here. You're going to we can rectify this. This is minus here. Okay, so the first one will be a divided by x minus 1. Since this is the quadratic, so quadratic factor will be written, and in numerator we will have the linear factor bx plus c. Now it is, since it is in repetition, so again here we will have the whole square, and after c we will have dx plus e. Okay, now we have to multiply both sides by the LCM, so we'll get x square here. You can see that what will get cancelled, with x minus 1 we will get cancelled, and with a we will just have this factor, then bx plus c, so this one will get cancelled, and we will have x square plus 1 one time. Moreover, we will have x minus 1 as well. With dx square we will just have x minus 1. If you don't understand this shortcut way, so you can go with multiplying with LCM with each term that we have been doing or we used to do in class 9th. Okay, here now we can see that this is a whole square bracket, and for expansion we have to first of all eliminate the square by expanding it. So x square plus 1 whole square means a plus b whole square. So this will be a square 2ab plus b square. Fine. Bx plus c is written as it is for now. Then these two brackets are multiplied. X square with x cube, x square with 1 minus x with 1 x, and 1 with 1 minus 1. Then dx with x, dx square, here this is this one, and dx with 1 dx, and ex with e with x ex, and e1 is minus e. Fine. Okay, now this and the next it has been, okay, we can see here that bx plus c is also multiplied with this whole bracket. So bx when multiplied with x cube will get bx4, and bx when multiplied with x square, so we'll get bx cube. Then bx should be multiplied with x, so bx square. Then bx should be multiplied with minus 1, so minus bx. Same is the case, c should be multiplied with x cube, cx cube, then cx square, then cx, then minus c, and this is written as it is again here. Fine. Okay, next step, this equation is arranged. x4 is written first, then x cube are written, then x square is written, then x linear terms are written, then constant term. If you will arrange it, it will help you easy, it will help you in equating the coefficients easily. So here one value can be found out by putting x is equal to 1. Remember one thing, that if you have linear factors, so you must derive the value of x from that linear factor and put in equation in order to find one of the unknown values. Then you can go with the equating coefficient methods. Fine. So let's put x is equal to 1 in the equation. So let's see that which value will be found out. We'll put x is equal to 1 in the equation here, then we can find the value of a. The rest value will get 0. Why? You can see here as it has become so rough, but see, if you will put here 1, we can do it directly. 1 minus 1, 0. So this whole expression will get 0. If you will put 1 here, 1 minus 1, 0. So this whole will get 0, because when any number is multiplied with 0, it will result in 0. So just this is left. So you can do it directly, it doesn't matter. So here the rest will get 0. I can write it for you here, that plus this one will get 0 and this one will also get 0. So just a is here. A will not get 0 because of whole square. Whole square will never make it 0. The negative will also turn into positive then. Okay, 1 plus 1, 2, so 2 2s are 4 here, and the value of a will be 1 upon 4. Now one value is found out. The rest values can be found out with the help of equating the coefficients, because we don't have any other value of x. So let's go ahead. Equating the coefficient of x4, then x cube, then x square, and x. In the same way we have to go. You can find now x4 here. A plus b is equal to 0 will be first equation, minus b plus c is equal to 0 will be the second equation. Now x square will be 2a plus b minus c plus d is equal to 1 will be the next equation. Then let's see the terms with the x, minus b plus c minus d plus e will be the next equation. So here you can see equating coefficient of x4, then equating coefficient of x cube, then equating coefficient of x square. These are all the coefficient of x square, and these are the coefficient of x, or either you can equate the constant term, or this, up to you, it doesn't matter. So if you put the value of a is equal to 4 in this equation, so we'll get the value of b. When we will put the value of b in this equation, we will get the value of c here, as you can see. Okay, when we will put the value of b, a, b, and c, so we can get the value of d. These are easy. You can, the value of a, b, and c, if you will put, so we will get the value of d. Here you can see 2 1 is 2, 2 2s are 4, and here you can see, okay, fine, plus minus 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 plus, here this one will get cancelled, and we will have just 1 upon 2 plus d is equal to 1, and here we can take the LCM. So from 1 if you will subtract half, so again you of course you will get half 1 upon 2. Okay, now we can put the value of b, c and d. You can see b, c and d, then you can get the value of e. So by putting these values you can easily get the value of e. Now we can put this in the equation and you will get the required partial fractions. Here this is the value of a, this is the value of b, then c, then d, then e. Fine. As 4 is the common denominator, it can be written here. Okay, 1 upon 4, then 1 upon 4. Here you can see that minus is taken common. If minus is taken common, so x will be with plus, and this minus is also taken common, so plus is left. So 2 is written in denominator, then x plus 1 is left. This is the required partial fraction. Here we have the last question of this exercise. Okay, here you can see that I have already told you that if it is, you must see that whether the fraction is proper or improper fraction. We can see here that this is, the numerator is raised to the power 5. Okay, whereas the denominator, if you see the power of this 2 and 2, so it will result in 4. It means it is improper fraction because numerator is greater. So if numerator is greater, it means division is possible. This fraction can be converted into proper fraction. So let's do it. Before it, you have to expand this bracket for the purpose of division here. So a plus b whole square. So a square 2ab plus b square. Formula is applied here. Then we have to go with the division. Inside x5 is written and denominator or the divisor is this one, x4. Fine. Now you see that here x4 and here is x5, so we should multiply it by x. x4 with x, x5, 2x cube, and x with x, x with 1x. Okay, this one will get cancelled and minus 2x minus x here. Students, remember one thing, that when the expression starts with minus sign, so it will make complications and it will create some confusions. So therefore it's better to take minus common in order to make this expression positive. It will be better. So here therefore minus is taken common. Now we have this x cube. X cube is less than x4, so it means it is converted into proper fraction. So let's write this in mixed fraction form. X will come as a whole here. Fine. Here y minus sign, you can see that because plus minus will minus, so minus sign will come, then the remainder, then the divisor. Fine. Okay, now as I told you that you are going to ignore x for a while and you are going to take this remainder, the partial fractions of this remainder should be met. So here as the same procedure will be used as this is quadratic, so ax plus b, as it is repeated again, so square cx plus d. We are going to multiply by the LCM and as a result we will get this. By expansion means this both brackets should be multiplied, and then here it is arranged x cube, x squared, then x, then constant term. Now we cannot put the value of x, so therefore we will go with the equating coefficient method. So we have to equate the coefficient of x cube, x square, x, and constant, because 4 values are unknown, so 4 equations are made here. Okay, by equating coefficient of x cube, you can see that x cube is equal to 2x cube. So the value of a will be 2. Then x square, we don't have any x square to this side of the equation, so b will be equal to 0 then. Fine. And the next one will be coefficient of x, a plus c, and this side we have the coefficient of x as 1. So a plus c, 1 will be the next coefficient of x, and then we have the constant term, you can see b plus d. Here we don't have any constant term, so b plus d will be equal to 0. So okay, the value of a and b are already found. Now by putting the value of a in this equation we get the value of c, and by putting the value of b in the equation 3 we can get the value of d here. So here we have the values. We are supposed to put this back into the equation here. Okay, here you can see that as this equation was equal to, you can see here we have x minus. So x minus should be written. You are not going to ignore that. X minus is written. Then because it is minus sign, so minus will be with all these partial fractions, so therefore bracket is put. You are not going to ignore the bracket. Bracket is necessary. Okay, this is 2x. Okay, here we'll have minus x here, plus minus minus you will get. Okay, now this bracket should be eliminated. It will be, now minus is with this and minus 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 result in plus, so there should not be any bracket now. This is the final answer, means this is the resultant partial fraction of this resultant fraction. Okay, here we are done with exercise 4.2 and the chapter is completed. Tomorrow inshallah we'll go with revision or assessment and your presentation. We have now the homework for tomorrow, or for homework for today is exercise 4.4. You are going to attempt in your neat notebook. Moreover, you have to prepare the presentation of 4.1, 4.2, 4.3 and 4.4. And means any student can be asked to share the screen and explain the means one question from these given exercises. This is all for today. Have a nice time. Stay blessed.